Microsoft Excel has a lot of really interesting built-in templates that let you do a wide variety of calculations. For today, I want to look at one of the templates that lets you do some loan calculations. And this template is interesting not only from a financial perspective, if you're future home buyer, you're looking to take out a car loan. It's also interesting in terms of kind of what this lets us do from a mathematical modeling perspective. So what I'm going to do here, I'm going to go to File and New. And you see your most recent options up here. I'm going to go down here and type in loan. And okay, so we got a whole lot of options. This loan amortization schedule here, this is the one I use a lot when I'm teaching class because it's very pretty. It's got a lot of nice formulas, a lot of nice columns and colors and headers and that kind of thing. I'm going to just look at this one today, the simple loan calculator, because it is simple, right? It's going to let us just look at the features we're interested in. So you see, it's got your basic loan information here. Let's say we're taking out a car loan, so let's make it a decent car. Let's say 35,000, and we'll knock this down to 5%. 5 years is pretty standard for a car loan, and let's say the start of the loan was 6/1. Okay, so now it's done some calculations for us, right? The monthly payment is going to be $660.49. The total number of payments, so that's just 5 times 12, so that's 60. And it's also calculated the total interest we're going to pay and the total cost of the loan, which are also kind of nice things to know. Right? So from a finance perspective, that really is the heart of what you want to know, right? You know how much you're going to be paying every month, you know how much you're going to pay altogether, how much in interest. What happens down here in the bottom section is really more interesting. This is what's called an amortization schedule. So what this does is it tells us everything that happened in that loan by week. So you see, if I scroll down here real quick, there's going to be a total of 60 rows here, right? One for each payment. All right, so let's go back up to the top. Let's see what happens in week 1. Right, we make our first payment on July 1st. At that point, the beginning balance is still $35,000. We write a check for $660.49, and what happens? Well, $514.66 of that went toward the principal, went to actually pay off the loan. The remaining $145.83 went to interest. That just went straight to the bank. And the ending balance, the total amount we still owe, is this $34.45. And you can double check that. That is the beginning balance number minus the principal number. And then it's done this for every month, right? So I can go down here and I can see at the end of the second year after payment 24, the amount I owe is down to $22,000. In my younger days, I would buy a car and I would keep it until the amount left on the loan was equal to the trade-in value of the car. And then I would trade it in and get a new one, right? Because the trade-in value was exactly enough to pay off the loan, and I would basically be starting over. So this is helpful for that, because if you know what the current trade-in value of your car is, you can scroll down here until you find that amount. You know how many months it's going to take you, right, to get to that point. All right, so let's look at this now, maybe from more of a modeling perspective. I'm curious what's happening with these principal numbers, because I notice they're changing. The same amount is not going to principal every week, and the reason behind that is because every week you owe less, which means the interest is less, which means the principal is going to be more. Right, but I'm interested in the trend here. What's going on? So let's take a look. I'm going to do week 2 minus week 1, and I see that there was a change of $2.14. Right, $2.14 more went to principal. So let's copy this down And a little faster. I'm going to go all the way down to 60. And yeah, I see that trend continues. This number is increasing. Not necessarily strictly increasing. I saw one earlier where, yeah, I saw one earlier where there were two numbers that were the same. Yeah, there we go. Just the way the numbers worked out, it stayed the same between payment 12 and 13. So it's increasing, although maybe not strictly increasing. And okay, so that's interesting to see. I'm not seeing a huge change, right? We're going from 214 up here. I don't think we even made it to $3 by the time we got to payment 60. No, we didn't. Okay, so I'm saying, okay, well let's experiment, right? When we're trying to model things, that's what we do, right? There's an element of experimenting to this. So I'm going to say, let's try a bigger loan. Let's knock this up to 250,000. Make it a house loan, for example. And let's leave the 5% the same, and we'll change the 5 to 30. And that's a fairly standard amount. 15 and 30 are the standard periods for a home loan. Now, I want you to see what this did here. First, you can see it right here. Excel added additional rows. Right now, we go all the way. If we go down to the end here, right? If I jump, whoops, oh, sorry, I went way too far. If I go all the way down to the end, we get to row 360, right? And that is anytime now. Almost there. There you go. And that's our final result. And yeah, after the 360th payment, the balance goes to 0. Okay, so let's repeat my calculation now. Let's scroll up some and copy almost there. There, copy my formula down the rest of the way down to 360. Let's see what happens, right? A little bit further. There. Well, okay. Now we went from it's $1 something up here, and it was $5.50 if you saw real quick before I started scrolling. So that's a more substantial increase, right? And mind you, that's just the month-on-month increase. If you look at the raw numbers, we go from just 300. That's less than a. This maybe a quarter of the payment. And if we scroll down here all the way to the end, almost there, it's gone up to, look at that, it's over 1,000, right? In these last payments, almost and now we can really see what's going on, right? By the time we get here to the end, the situation is reversed. Instead of most of the payment going to interest, most of the payment is going to principal. And again, now that we're seeing the numbers, that kind of makes sense because the balance is dropping, and every time the balance drops, the interest we owe drops. Okay, that's nice, but now running into a classic statistical problem. I'm seeing a lot of numbers here, and it's great that we've got this much data, but just looking at all these raw numbers just is not really telling me much. Right, so what I'm going to do next here, I'm going to say, and again, Excel is our friend here, I'm going to, whoops, wrong way. Let's jump down to the end, and I'm going to jump up to the top. What I'm going to do here, once I've got these numbers selected, I'm going to graph this and see what happens. So let's come up here. And I'm going to convince my laptop to let me select this. There we go. So I've selected all of the principal numbers. And let's go up here, insert, and I'm going to do, let's try doing this with markers and see what that looks like. Okay. Does not look very good. And I'll tell you why in a second. I'm going to cut this. I'm going to paste it up here where I got a little more room. Okay, so what's going on? Down here, these are the payment numbers. I know I didn't enter something for that. Excel has just numbered them sequentially which is what we want. Well, one thing, first, you notice how thick this line is. That's because of those. That's because of those line markers. So let's go up here, and I'm going to go to charts, and I'm going to pick this one, and I'm just going to change the chart type. Right? Let's just change it to. That's a little better. Right? It's a little less clunky. What immediately stands out to me here is that this is not a linear relationship. Right, so if I'm trying to model how this is changing over time, right here Excel has given me some very valuable information. Right, I know that a linear model is not going to work. And now what I'd really like to see, let me add something here. I'm going to go to Select Data. And first let me select this series. I'm going to edit this. This is principal. Let's give it a label so it's clear what it is. Then I'm going to add, whoops, let's go back in here. I'm going to copy the range of cells that this came from. And I'm going to add another data series. Right, so let's go down here. Now I'm going to change these F's to G's. You notice column G is the interest column. And let's change this to interest. Give it a decent label. And you see Excel is ahead of me. It's already done it over there. Right? There we go. Now, I'm really starting to see what's going on. I'm starting to see, first, that both of these are definitely not linear. And I'm also seeing the relationship between them, right? And I'm seeing how though they're both kind of changing at the same rate, just going in different directions. And that kind of makes sense because remember that the sum of these two numbers is constant. The sum of these numbers is always $1,342.05, the total amount that we paid. Right? So, hopefully you've seen a few things here, not both from a financial perspective, how you can use this in a practical situation, and how we can do some kind of basic data modeling things using Excel's formula abilities, its automatic calculating abilities when it did a lot of those principal and interest calculations for us, and its charting abilities to get kind of a very high level view of what the data is doing, which from a mathematical modeling perspective is going to point us in the direction of what kind of model we want to choose to describe this data.